Hello, young math Padawans. It's Mrs. Angel with a quick lesson for today on equations with different numbers of solutions. So this statement at the top here pretty much sums up what we're going to be talking about. Not all equations have one specific solution. Some equations are always true. And when an equation is always true, that means it doesn't matter what value of the variable you pick, the left side of the equation will always be equal to the right side of the equation. Other equations are never true, meaning the opposite. It doesn't matter what value of the variable I choose, the left side of the equation will never equal the right side of the equation. But how do we determine which is which? How do we find the equations that are always true, sometimes true, and never true? That's where today's lesson comes in. So grab these notes and let's get started. Example 1 is already kind of telling us what we're looking at. We're going to look at an equation with infinite solutions. And infinite solutions just means the equation is always true. So let's take a look at this equation a little bit closer and see why is this an equation with infinite solutions. As always, I start by putting a line down the middle of my equal sign. That way it separates the left side from the right. And thinking back to the tools in my solving equations toolbox, I see some parentheses here on the left, which means the first tool I'm going to use is the distributive property. Let's get rid of those parentheses. Now let's go in and simplify. 2 times 3x is 6x. Minus 2 times 12 is 24. On the right-hand side, we're just going to bring down our 6x minus 24. Hold on, something looks a little bit strange about this equation. Do you notice something about the left side of the equation and the right side of the equation here? How about the fact that they're the exact same expression, which means this equation is always true. There isn't a number that I could plug in for x on the left that wouldn't produce the same output as the number on the right. So at this point, I already know this equation has infinite solutions and is always true. And here's how I know that. Instead of checking, we're just going to do an explanation here. The explanation would be if you have the exact same expression on both sides of the equation, your equation is always true. So if we wanted to, we could actually stop here and go on to the next one. However, I have a feeling some of you don't see what I see and you would want to keep going. So we're going to keep going and determine another way that we can tell that this equation is always true. If we were to continue solving this equation, I do notice that we have 2 terms on the left-hand side of the equation and 2 terms on the right-hand side, which means I need to pick one of these terms and change them into a 0. Now, I like to use the variable terms first. That way it gets all of my variable terms on one side. So if I choose to create a 0 term out of 6x or 6x, it's actually the same math. To make 0 out of 6x here, I would have to subtract 6x. Same over here. That's weird. Let's see what happens when we do that. So by subtracting 6x on the left, subtracting 6x on the right using our subtraction property of equality, let's go in and simplify. 6x minus 6x is 0, which leaves me with a negative 24 on the left. Equal sign on the line, 6x minus 6x is also 0, leaving me with a negative 24 on the right. Notice our variables are now gone. They've been eliminated. They both became 0 terms, and I'm left with an equation that is true. Does negative 24 equal negative 24? Yeah, it does. And if you end up with an equation that's true, that means it's always true, and it actually doesn't matter what x equals. So to explain in words how we know now that this equation has infinite solutions is that after using all of our properties of equality, we ended up with an equation that is always true, meaning this equation that we started with is also always true. So there's two different ways to determine if an equation has infinite solutions. You either want to look for the exact same expression on both sides, or after using all of your properties of equality, do you have an equation that is always true? If that's the case, then this equation, 2 times the group of 3x minus 12 equals 6x minus 24, has infinitely many solutions or all real numbers. I challenge you to find a value for x that does not create equal values on both sides of this equation when you plug it in. Moving on now to example 2. Again, the notes are already telling us what to expect. In this example, we are looking at an equation that has no solution. And no solution means it's never true. So it doesn't matter what value you choose for x, this equation is never going to be true. Let's look at why. I'll start by putting the line down the middle of my equal sign, keeping the left side separate from the right. And similar to example 1, I see some parentheses. I'm going to use my distributive property to get rid of those parentheses so I can see the individual terms. The left side of my equation is not going to be affected. I still have my two terms, 8x minus 10. But my right side of the equation, I'm going to multiply 4 by 2x and 4 by 5. 4 times 2x is 8x. 4 times a plus 5 gives us a plus 10. Now after we simplify, do you see something kind of interesting here? We have an 8x minus 10 on the left, but an 8x plus 10 on the right. What do you notice? Well, I notice they have the exact same starting value. They both start with the product 8x, but unlike example 1, they have two different changes. On the left side of the equation, I have 8x minus 10, and on the right side, 8x plus 10. How is that ever going to be true? How can I have a number and subtract 10 and expect that to be the same as the number plus 10? At this point, because we have expressions with the same starting value and different changes, we know this equation has no solution and will never be true. So rather than doing a check, let's just explain kind of what I just said there. How do we know this equation has no solution? Well, first of all, it has the exact same variable term. We're starting with 8x on the left and we're starting with 8x on the right. But different changes. Here I'm subtracting 10, and here I'm adding 10. That's how we know this equation is never true. But again, some of you might have a hard time seeing that. So let's go back and continue solving and see what happens. So again, I'm noticing that I have two terms here on the left and two terms on the right. So I have to choose one to make 0, and I always like making 0 out of the variable term, so that's where I'm going to start. My variable terms are an 8x on the left and an 8x on the right, or the right and the left. How do I make a 0 out of 8x? I would have to subtract 8x. Subtract 8x using our subtraction property of equality. Let's see what happens after we simplify. 8x minus 8x is 0, and on the left we have, careful, negative 10. On the right, 8x minus 8x is also 0. I've now created two 0 terms. That's a red flag. And on the right, it simplifies to positive 10. Now here's what you have to look for. Does negative 10 equal 10? Is that true? Not the last time I checked. This is false. Negative 10 doesn't equal positive 10. Well, if you use all of your properties of equality and you end up with an equation that's false, that means it's always false or never true, and there is no solution here. So another way that we can tell that this equation has no solution is, after using our properties of equality, the final equation, negative 10 equals 10, is never true. In fact, because of that, we can put this line down the middle of the equal sign to show there's no solution here. Doesn't matter what you plug in for x, this equation will never be true. So just to recap, not all equations have one specific solution, and there's two ways to figure it out. One way is to get it down to two terms on one side and two terms on another, and look for the exact same expression or the same variable term with different changes. Another way is just keep going, keep solving and simplifying until you get down to an equation that's always true or always false, and that will let you know if it's infinite solutions or no solutions. That's it for today's lesson. I will see you next time.